Welcome back, and we have one last video about probability. This one, we've had stuff when it's independent. This time things will be not independent, and you'll see that you can use a lot of the same principles. So we're going to use 3 dice that are not cubes. If you have played Dungeons and Dragons or had to subject yourself to people playing Dungeons and Dragons, you've seen dice like these. We have 3 dice. 2 of them are so-called D20s. They have 20 sides, numbered 1 through 20. These are icosahedra. And the other one has 8 sides. It's a D8. Okay? And here's the deal. You got these 3 dice. You're going to pick one at random and roll it. You're not going to add anything. You're just going to roll 1 die after picking it at random from among the 3. The big question is, what's the probability that the number you roll is 3? Okay, remember you're going to roll 1 die. How are we going to do this? Well, we're going to use exactly the same principle as we did before with the area model. So this rectangle represents all the possibilities. We're going to divide it up into 3 parts because choosing the 3 dice are equally likely. Now, in real life, when you reach into the bag, you can tell which one is which. But let's pretend that there's equally likely whether you pick one die or the other. So that's one of them. There's the second die. And here's the third die. Now those 2 kind of browny beigey things are really all one segment. So we have these 2 segments here. The top has a probability of 2/3. The bottom has a probability of 1/3. 2/3 plus 1/3 is 1. Probability of 1 that something will happen. 2/3 that it'll be the brown 20-sided die. 1/3 that it'll be the blue 8-sided die. Now we're going to go the other direction and divide it up into columns. Let's see how this looks. Okay, so the 20-sided die, we're going to divide it into 20 pieces, and we're not going to do all the graphics. We're just going to put 3 dots, and then at the end there's 19 and 20. Now the 8-sided die, of course, we divide up into 8 pieces. We won't do those separately, but that's what it's going to look like. At this point, let's just notice that the diagram makes perfect sense in terms of what's going on, but it's no longer the case that the vertical lines always cross at the same place. So there is an association between number and which die it is. The number is not independent of the other die, but because we divide it up in this way, we can still use the area model. So what are we going to do with this area model? Let's see. We need the area of individual cells. You could see down at the 6 that at the bottom they're 1/8 wide. The top ones are 1/20 wide, 1/20 of the width of the rectangle. And so at this point, let's just take a little area check-in and recall that the box represents all possibilities. So it has a width of 1, those 20 things that are 1/20, and it has a height of 1. So the area of the whole box is 1. The area of the whole box represents the probability that something happens. That's 1. Okay, now we're going to focus on our particular things that we're interested in this case, the 2 3s, because we want to know what's the probability that you roll a 3. Up at the top, you see the stripe, which represents the probability that the 3 that you roll is on the 20-sided die. Down at the bottom in the blue list is where the 3 that you roll is on the 8-sided blue die. We need to figure out the areas of those 2 rectangles, and so we'll just measure them this way. We're going to look at the top one first. That's 1/20 times 2/3, which is 2/60. Look at the bottom one, and the width is 1/8, the height is 1/3. That's 1/24. In order to find the probability we need, we're just going to add the 2 together. So let's do that. We'll put those off to the side. The total area is the probability. 2/60 plus 1/24. You can do it on your calculator, but if you're a glutton for punishment, use fractions. Common denominators are 120. It makes 4 120ths plus 5. That makes 9/120, which is 0.075, and that's the probability of rolling a 3. Well done, everybody. Do the homework. See ya.